welcome back. In lecture 48, we will start with travel demand modeling, and we will cover both the CUBE and the Visum software. So, the different concepts that will be covered in this lecture will be on travel demand modeling using the CUBE Voyager software, and within that we will look into trip generation, trip distribution, mode choice and traffic assignment, and then we will also look into travel demand modeling using the Visum software as well. So, we have already seen the basic structure of the CUBE software. So, within that we will work with the CUBE Voyager component, and as you can see in this particular slide, we are it shows the modeling framework that is used in this particular software. So, in the 4-stage travel demand model, we have trip generation, trip distribution, mode choice and traffic assignment. So, these are the 4 steps, but before even we start these 4 steps, we have to start with some basic data sets. For example, we have to have data on different zones, we have to have data on the different networks. That means what kind of travel time it takes to reach between one zone to another, and that is based on both passenger highway, the road traveling along roads, as well as passenger traveling using public transit. So, all these things has to be initialized first, and then we start with the actual 4-step travel demand modeling process. So, this first steps we use CUBE Base and CUBE GIS, and then this 4-step model is actually done with CUBE Base, CUBE Voyager as well as CUBE Avenue. All the different components are used, and then finally after traffic assignment is done, we can generate reports and we can analyze the different metrics that are created, and here we would use CUBE Reports, CUBE GIS, and also we can use CUBE Analyst. So, this is how we can use the different components of CUBEs, but primarily we can use CUBE Voyager to actually work this particular to complete the travel demand modeling process. So, this is the basic starting screen where you can see in the first screen we are seeing the different initial inputs that has to be provided to the software. We have already discussed about the way Voyager presents its different components. That means everything is organized in such a way so that it is easily understandable and legible. So, the blue boxes over this side is the input and the green is the output, and over here is the actual process. So, here we start with initialization, and once initialization actually means we calculate the different cost of public transit for walking to the public transit, then the cost of the highway, and then we also start with the seed matrix, and this actually is generated from the different files, which includes the public transit line, the highway network, the fares and so on, the walk access to public transit and so onwards. So, all this data is actually utilized to determine the different input data sets that are required for this particular, for doing a 4-stage travel demand model. So, we see that highway network data is required. Similarly, we require data related to different modes, network and then fare, accessibility. Then we require intersection data over here. Intersection data actually gives us the time taken during congestion and so on. Then demographics and external trips. So, demographics and external trips is shown over here, which is directly an input to the trip generation model. So, over this side are the 4 models that we use. So, this is trip generation with both inputs and outputs. So, input is demographics and external trips, and then of course, the network distances, also the network cost, the network scheme tables are also taken as input, but for trip generation itself we do not require the network scheme table, but for trip distribution we require the network scheme tables, and over here we get the trip ends. And once the trip ends are known, we can move on to the trip distribution module, and from there to mode choice, and then there to assignment. In trip distribution, we have the cost of passenger of highway network, and the trip ends we also will get and then using these 2 things we can actually distribute the trips. And finally, whatever the matrix is generated at the end, this % trip matrix, that actually goes as input for the mode choice model, from where we can, using the other data sets, we can actually have trips by different mode. And finally, trips by different mode could be actually assigned as per different time of the day and as per the different the way we divide that and divide this total trips into different hourly rates, and that actually is used to assign this trips by different modes for different time of the day for this particular network. So, finally, after this process we also have trips by mode, trips by purpose and loads by mode in the network, and then we can also generate reports from this model. So, first we will start with trip generation. So, as we have already discussed, Cube Voyager or any Cube software uses scripts. Scripts are instruction sets which are given which are executed when they are called. So, these are basically programs. So, these programs could be customized, but in this the first program is for trip generation. Like any program, it has got inputs, then it does some processing, maybe it does also some certain loops, and after that it gives some output. So, over here we can say at the beginning we have the initial files that has to be entered. So, over here we can see these are zonal variables are referenced in script as z1x variables. So, file 1 z det 1. So, this is the first one, and so these zonal variables actually include data about the different zones, and then lookup tables contain production and attraction rates. So, that is there in z dat 2. And then file OOPAO, this is the output file, contains production and attraction to be used in the distribution phase. So, this is the output file. So, that is what we are specifying at the beginning. Then in parameters we define the total number of zones over here, and then in the I loop we actually do the estimates for, we calculate the productions and attractions for different kinds of trips and different kinds of zones, and this for different kinds of trips and for all the zones, and that is why we will run it in a loop for executing it zone by zone. So, here we are dealing with 3 kinds of trips. So, that is why we have got 3 productions and 3 attractions. So, over here in this page we can see that these are the equations that has been used. So, P1, P2, P3 are the 3 productions for 3 kinds of or predicting productions for 3 kinds of trips for each zone. So, these are the equations that has been used, and A1, A2, A3 are predicting attractions for this different zones for this 3 kinds of trips. For example, A1, this is home based walk trip. So, here total employee is the use for prediction. So, similarly for others we have used other variables. So, as we can see in trip generation, entry is household, the data for this each zone is includes household sizes, lengths and area of TAZ, number of employments in TAZ, retail shops in TAZ, services to generate trip attraction and production for a particular zone. So, all these things are listed, and then external trips from the zone, this is also given in zonal data 1, and finally zonal data 2 DVF, we have data on total number of trips per day with categorization on productions and attraction and home based trips and home based non-work trips and non-home based trips and external trips. So, this is the total data that would be actually these are the total data that is required. So, now just let us see a video of this entire process, how it is done. So, we open Cube 6.4.5 version, we import the data, and so we already a file is there, a training.tpl file, already we have created that. So, we start that, and this then we have to add a new template, and we add the template name as training model, and finally, we can start an application. Over here within this application we will actually first give a this group name TM and group code is Voyager, because we are creating a Voyager application, and then after that we need to create this we are starting with generation. So, I will just go this side. So, generation, so these are the inputs to generation. So, we are creating a training model, and here we are giving the entering the number of zones. The equations are already given over here. So, we have already, because we are using existing model, and then we have to also include the data that taken as input, and so we are taking the data, and see here we can have the different files. We remove the unused files. So, these are the script file, this is the program file, this is the zonal data 1, zonal data 2 that we have already discussed. I will again go back once more, and So, after that we can have the print file, and these are the results, and then we can click on that model and we can run it, and this is the result that we get. So, we see that for P1, P2, P3, P4, for each zone there are 25 zones, 16 are internal zones, the rest are external zones. So, when we double click on the generation application box, then the model is run, and we can also click on the tripends DBF, and which is where all the data for production attraction is stored, and then when we click on that we can see the final results. So, here are the attractions for each of the zones, and these are the productions for each of the zones. Next, after this step we have to do the trip distribution step, and as you know, trip distribution is a function of both production and attraction and zone to zone travel cost. So, the first step is to determine the zone to zone travel cost. So, once it is done, then we have to link we have to open the trip generation component file that we have already done, and then we have to link this network and trip generation along to this new trip distribution program, and these as inputs, and automatically when we run the distribution program we have to first enter certain other information. For example, trip distribution model, if we use a gravity model, it has got certain inputs and it has to be calibrated to match surveyed trip length distribution. So, for that we have determined these F factors and also the K factors. So, for F factors, if they are already determined, we have to get it from another file, or we have to either solve it, or we have to calibrate the model and then decide on this F factors, and we have to save it as a file, and then we have to open this file within this model, and then we can execute the trip distribution model to get the final results. So, trip distribution in Cube Voyager could be done with Freta model for external trips, gravity model where we can use friction factors and K factors, and we can also have very complicated destination choice model in the logit form, and over here we will be using the gravity model, and this destination choice model we will show in the next lecture when we will do a activity based model. So, the entry data, zonal data 1, zonal data 2, same as earlier. Then we also have got tripends DBF, which was generated in the previous step, and then we required the new data required is highway scheme dot metrics and this PT cost dot metrics. So, this actually gives us the metrics on highway users, or basically car users, zone wise in terms of travel time and distance, and PT cost dot metrics give us metrics on public transit cost from one zone to another. So, this is public transit generalized cost, and this is the total travel time or distance or impedance between the different zones. And F factor DBF is another file that we have already prepared. This contains the data on impedance for gravity model. So, these are the friction factors that we have already stored. So, when we run the model, the script, if you open the script, you will see a script something like that with some variations maybe. So, if you see the script starting over here, so this is the actual model that is being run. So, we see it is a gravity model, purpose is given, purpose gravity command performs gravity model distribution, purpose is the number of trip purposes. So, we have got 4 purposes. So, the first 3 trip purposes we already discussed, the 4 is for returning trips and so on. And LOS, this actually is the matrix, these are matrices which include the cost matrices, travel time, cost, distance and so on, and that is for this particular for running the gravity model. Then we have the friction factors, which defines the impedance curve in minutes by purpose. So, friction factor, if you remember from the trip distribution, we have to first generate this friction factors, it is an equation basically. And then we have got a K factors matrix that is not here, but it could also be there. We can also include that. These are zone specific variables, adjusted variables. This we have also discussed when we have done trip distribution. So, finally, we have to define, we have to balance the total amount of production with total amount of attraction, and that is done over here. So, set PA, this is set P and A. So, that is production and attraction. So, that we have to also balance the in between the different trips. So, this is how we write the script for trip distribution. Let us see how it works. So, first we have to create a network scheme and we have to open a file from application, and over here again we are starting with Voyager. So, we are doing highway scheming, and this is the highway file. If I click on that, then it will run, and this, after successful run, it will actually show us the different travel times. Similarly, we do it for public transit, and in public transit, similarly we can do over here. We can build the PT network and extract cost, and so we have to save this data one by one, and that's why we are putting all this file names over here and over here, and then PT composite cost file name, and again this is the initial one was network file name, and so onward. So we give all these files their names and we save them, and some system files are also generated. Then we can clean this up. So we have got highway and public transit, so we separate them up. So these are the data required for highways. We have the script file and the network file. For public transit, we have fares and all the line information and all. Then we execute that, and when we execute this, this is filled. So now we have the different matrices having the different cost. Then we start the trip distribution application. So this is not generation, this would be distribution. So we start with generation, and then we will then move on to include the network scheme. So we open the network scheme file, which we have already saved, and then the network scheme comes, and then network scheme we save this within this particular application, and we organize that. We have highway and we have this public transit, and so first we have to make some of these files as publics because we are going to use them, and once we have done that, so we will use these files directly. And then once we do that, then we will go back to the parent mode. So all the cost and all these things have been made public now. So we go back to the parent mode and where we move into, and then we will start doing the distribution. And now over here we have both the network schemes and the generation data. The next step would be to add the distribution. And we also do change the execution sequence. Network scheme is first and generation becomes second. So once we execute the network, we get the data for the network, then we can add data from, then we execute the generation. So because it will use data from generation. And once that is done, then we have to do it for the three kinds of trip again. And we also include the F factors DF because we have to run the trip distribution model. We include the friction factors file as well. And once it is done, see here is distribution. So we can have this different files. Then we will link this different with generation as well as network. So the first trip ends will be loaded over here. And then over here from matrix file 1, highway matrix would be also loaded over here. And so this is actually becoming more clearer. So trip distribution starts with zonal data, it starts with the matrix file, and we have the script file as well. And then we can run it and we save the data in %trips.mat, not for trip generation, this would be trip distribution, final result. We save that in %trips.mat because we will require this file in the next stage when we do assignment as well. And so once it is done, we then execute it. In mode choice, we will require %trips.mat, and then we can click or double click on distribution. We will make it, this will run, and we can click OK, and then we can go to this matrix file, and then we can take a look how our %trips.mat file looks like. So we see our matrix is now populated with all the different trip interzonal volumes for different trips. So these are the 3 different kinds of trips, 4 different kinds of trips, and how the different we have got interzonal volumes for each kind of trip. Next we go into mode choice, and in mode choice model in Cube Voyager we can have different kinds of model built. For example, we can go for a multinomial logit model, we can go for a nested choice model, we can go for again a mode and destination choice model, combined model. So this actually provides something called a matrix program function to implement the mode choice models. So, it is called a matrix program function, and it has got like a mode choice. It has got, we have to first develop the utility equations for the mode choice. For that, we use several characteristics or influencing factors, such as characteristics of the trip maker, characteristics of the journey, characteristics of the transportation facility. All these things could be included in a mode choice model, which we have learned earlier. So, over here we have trip generation already done, and we also have done distribution. So, these are the two data sets we have got, and now we will go into mode choice. And over in this particular example, we show you the example with a multinomial logit model, and we will using that we will develop a mode choice model. And the defined script uses %trips, home based work, home based other, non home based, and 1n trips from trip distribution step, and then time, distance data, public transportation cost from street network data, and finally through trips data. So, these are the data that we will use to develop the mode choice model. So, this is the script used in mode choice, and as you can see, we generate the cost equivalent of time. So, these are some of the factors which are already given. So, for transit we do that, for walk we do that. So, we actually develop costs for each of this time, we convert time to cost. And here is the actual mode choice command, which is a X choice command. So, first part is defining of alternatives, where we define each alternative choice. Now, we are doing this X choice 3 times because of this 3 different for each trip purpose. And then demand MW defines input trip matrix to be split. So, this is the input trip matrix that has to be divided into the different modes. Costs MW defines cost metric for each alternative, and because the cost is also for this is the cost scheme. For example, from zone to zone we also have cost for each mode. So, this that is what is included over here in this particular matrix. And OD man DMW, this defines working matrices to store output trips. So, this is the output matrix. And then split is actually the type of mode choice model that we are going to use. And over here, so this is the type of mode choice model that we have used. So, car, PT, walk, these are the 3 mode choices that we will break. And we also use the scale, HBW scale, and then start MW is defines a walking matrix for internal calculations. So, this is for internal purposes, and then we have to develop the utility equations. So, after this we go into this step where we define utility equation for car, PT, walk, and so on, and using this we can run the mode choice model. So, this is the mode choice model. So, we have got network schemes, we have got generations, then we have got distribution. So, the next step is to run the mode choice model. So, these are the prerequisites. We will click on matrix from the Cube Voyager, and then select mode choice for 3 purposes and 3 modes, and then we have external.mat from training data, and we will just work for this is for external trips, and again we will select done when it is inputted. Then this is where we include the matrix. So, we will rearrange that to make it look better. We also now start linking this. So, the matrix files from distribution is added over here, and we add the other highway scheme matrix and output PT matrix, and for the public transit matrix, and then we go over here, and then we add this new files, and we can also save the files. And mode over here we are saving the files in this we are saving just a moment, I will just freeze it over here. So, modestrips.mat, this is the file where we are saving the data, and once we are done, then we click on the matrix over here, and then we can run this. And when we run that, then the mode choice using all the data that has been inputted, it would be run, and then we can see the run report as well. And this mode.trips.mat matrix contain all the data, and here you can see all the mode choices have been defined for different kinds of for the different interzonal volumes for each mode choice is actually given over here. So, this is how the mode choice model is run. Next, we move on to assignment. So, in the assignment model, if you remember from assignment lectures that we had done earlier. So, there are different types of assignment algorithms that can be used. So, over here in Cube, we have got different options. We can have multi-user class equilibrium. We can have average or weighted assignment. We can have incremental assignment with all or nothing. So, we have done this kind of assignments. We can also have multi-user class link and intersection constrained equilibrium assignment. So, we have done constrained equilibrium assignment, and over here intersection impedances or time spent at intersection is also taken. So, usually this kind of algorithms are there where actually the link cost function will actually be updated after each run. So, over here we can see that in any assignment we have to have link impedance and congestion. These are the two data that gets updated, and over here in this particular steps, we can see first step is of course setup. We initialize the variables and arrays. Then we have link read, where initialization of the link values, the first set of values. Then we have the loop, and here we loop for all zones, buildings, or and load minimum paths. That means in between each two zones, or even for buildings we can do that. We can load the minimum paths. So, we create the paths, and then we adjust revise link variable values, and then that means the impedance and congestion values will be adjusted, and then we check if we have arrived at a convergence. That means if the final error is within tolerance, or if we have arrived at a value which is not changing much, whichever is the convergence criteria, based on that we will keep on looping till this value remains. This value is more or less fixed. So, this is basically how we have learnt about trip assignment. The same steps is done. Additional thing that we have to also consider is time of the day factoring. So, from mode choice we have to first split the mode choice as per the different time of the day. So, that is the first step that we will do. So, trip tables are in production attraction form. We accept them in production attraction format, but the problem is return trips are not modeled separately. So, return trips are also there. So, we have got trips only in one way, and we assume it's to be same for trip generation, distribution, and mode split. So, we have the same set of values used for all these three steps. And so, production attraction is basically converted into origin destination. So, trip table is transposed, then added together and divided by 2. So, that actually helps us to create the total amount of travel between the different zones at different time points, because we are only developing production and attraction. Now, we have to change it into a 24-hour format. So, first we add the return home trips, and then divided by 2, then actually we arrive at in each direction what is the flow, and then we divide it as per the different time periods and so on, and time of the day factors are applied, which is basically the probability that the outbound or return trip occurs during a particular time period. So, we basically following survey data, we actually split the trip into different hours. So, once we have done that, then we are ready for assignment, and we can do it hourly assignment in the network. So, this is how the script looks like. So, if over here this is the start, and we start with the initial files, and then there is parameters and maxiters. So, parameters basically has got we specify the convergence method in one combine option, which is not here, but it could be added, and in maxiters we give the limit the total number of iterations. So, that also could be given. So, either we give a convergence method or we limit the total number of iterations. Both could be done, any one of them could be done. So, here it is maxiters. And link read function, this reference input link variables has L1 name, and working link variables, then LW names, add to group, define exclusion sets. So, these are the different functions. Then we have the I loop, where we can check for convergence. So, this is we first have to build the paths, each shortest path from I to all j, and then we have to do the assignment. So, this is the same. We have to first build the path, then we have to do link assignment, update the impedance function, then we have to return to the loop and again do it. So, that is how it is done. I will just take you through the process in a video. So, we start with generation, the network scheme, because this is the starting point for the iterations for assignment. So, we start with that. Is why these files are linked with this, this is the mode choice file. So, this is used by the mode choice, plus this would be also used by the final trip assignment as well, and we also take data from the mode choice. So, prerequisite model is trip generation, assignment and distribution, mode choice and distribution. Sorry. So, we first save the work folder and assign trip 0. So, we save the data like that. We enter assignment. First, we do occupancy adjustment by hour, because for vehicles we have to do for car trips we have to again divide it into as per occupancy. So, that is first being done, and then we have to divide it as per the time of the day factor. So, those two files we are including, and that goes as input, and then hourly matrix has to be created, and then we make these files public, and once it is done we first go back and we then generated the training model, and diurnal and occupancy factoring matrix is there. So, over here, and this is the final matrix that we are going to create, and over here is the linking between matrix file mode choice. Over here we are linking that over here, and with input matrix over here. So, we are linking that, and then we are saving changes to model 00. So, this is how we are linking this, and network file, this also is coming, and we are linking that in the different matrix. Next, we start the training model on single matrix equilibrium highway assignment. So, we are doing this kind of assignment. We go to we select the training single matrix equilibrium highway assignment, and then next, so we input the highway network file, and we name the output highway network file as loaded.net, and name the output time and distance scheme matrix as congested.mat, and define maximum iteration number as 10. So, these are the parameters that we have to set for running the equilibrium for the assignment model. So, this is only highway assignment, we are not doing a transit assignment. Then we are getting the output as hourly outputs. Then so, we make again the files public. So, for over here and here we are making the files public. Then once it is done, we go back. And then we go to the parent. We can click on this assignment, and then we can start running it. And this is the final data or output that we will get, and we get it in hourly outputs, and these are the hourly data. For each hour we will get the data, and 13 for every that entire 24-hour period we will get the data set. And so on. So, this is how we do the 4 steps in the in Cube, particularly Voyager, but as you can understand that it is very difficult to cover the different detailed steps. So, you can follow the video, you can go stepwise, you can freeze the video, and you can check into the different steps, and until unless you can get your hands on with the software, then you can actually learn the steps. But the target of this particular lecture is to give you an idea that whatever theory we have learned in the different steps, from starting from trip generation to then distribution, and then modal choice and trip assignment, and all this theory could be you can see in application when we are running this kind of a software. Each step is basically we have to, here the models, we are not making the models, we are just applying them. So, we are linking all the models and getting our final output, but the models has to be built using statistical softwares or using any other way. You can use Python as well. So, the models has to be developed. So, those has to be done independently, those cannot be done inside the software. The software is just for doing the linkages. That means, what is the input for the trip distribution model, what is the input for the trip generation model, and for each one we connect the inputs and outputs, and accordingly we get the final result. And because we are doing it for a bigger city, we are dealing with many links, we are dealing with many kinds of modes. So, without a software it becomes very cumbersome to deal with that. So, that is how this software actually helps us. Now, coming to travel demand modeling in Visum, this is the interface is a bit different compared to Cube. I will also take you through that. I will do it a bit faster. So, we can start importing a map in Visum directly, like in we can OpenStreetMap, we can navigate to we can open OpenStreetMap, navigate to the location, click export, and then we can open Visum and directly get that particular map. So, this is OpenStreetMap. This is the open source maps that are available in the net. And then we can go to Visum. This is the Visum interface, from where we can have import OpenStreetMaps, and here you can see that we can select the particular OpenStreetMap file that we have saved, and we can get the results. And when we do that, we get something like that, but it's a bit distorted. So, this is because the projection system may not be right. So, we can correct that by opening the background map, which is over here. So, that we can do through this, and then we can adjust the projections by clicking on this, and when we do that, we actually get the corrected map. So, once we have got the background map, now we can actually draw the nodes, links, and the different zones over this particular map, and we can create our network with different nodes, links, and so on. So, that is what we will do. So, over here is the basic interface. You can see that this is the network object window. So, from here we can draw the different nodes, links, turns, zones, connectors, main nodes, main turns, and so on. And this we can do it in both. This particular thing could be operated in both create mode or edit mode. So, we can create new nodes, we can edit the existing drawings, and so on. And this is the network editor overall. So, over here first we are clicking, we are creating a node, and click on the. So, this has been taken a screenshot from a video which is acknowledged over here, and this is a part of the training module. So, these training modules are there in internet, and you can look into YouTube videos. So, there will be quite a bit of training modules for Visum software. And we can click on the we can create nodes by clicking on the nodes tab in the network object window and switch to create mode. And first we have to be in the create mode, then only we can create something, and then click on the network editor base wherever we want to put the node, same as drawing any kind of in GIS or in a CAD software. It's the same process, and enter the then after we do that, we have to enter the properties of this new node, such as capacity, name, control type, and so on. So, these are what is given over here. Then the next step, I will show you how to create a link. So, a link is created by dragging between two nodes. So, over here we have done a link in the network editor, join two nodes to create a link, and enter the properties of this new link. We give a number to it, and then the type, use a drop down list to allocate link types, such as is it a motorway, is it a walkway, a road, and so on. And then also we say that will there be a link in the opposite direction. So, after that we can also create a zone tab, and we can create a new zone in the network object window, and then we can do that. And then once we have done that, then we have to give the properties of that particular zone, such as number, code, type, etc. And then we can draw the geometry or the shape of the zone on the network editor. So, this is how we have drawn the shape of the zone in the network editor. Once we have done that, we can connect this zone with the network using our connectors tab, and this is where we have said that a centroid zone could be connected to a network. So, that is what is being done over here. So, that is why we are using the connector tab, and in network editor draw a connector to join two zones and enter the properties of these connectors and click OK. So, that is how we can do the basic editing of the network in Visum. We have discussed the editing of network in Cube in the earlier lecture. So, once we have done that, for each zone we can also set some new transport system or modes. That means, what are the modes available over there. So, we can enter over here car and then train, walk, and other heavy occupancy vehicles. These are the ones which are available, and so this is what we can enter, and we can click on demand, and then on tsys/model/dsegs we can add that data over here. So, before we go into the 4-stage model, I would just like to highlight that in Visum there are certain concepts, like for example, there is something called person group. This is the classification of person or household based on some criteria. So, basically different socioeconomic groups that would be modeled. So, this could be low income group, middle income group, high income group, just an example, it could be anything. And then we have got activity pairs. This is something synonymous with trip purpose or external activity. So, it is called activity pair in this particular software. So, we can have home based walk trip, home based shopping trips, non home based trips, and so on. Then we have something called demand strata, where it's a demand object to calculate trip generation, trip distribution, and mode choice, and that is done for each group and each activity pair. That means, so each socioeconomic group, each type of trip, we will create both total number of trips generated, trips distributed, and mode choice. So, this is how we stratify the total demand. So, that is why it is called a demand strata. So, the demand strata is something like low income group with home based walk trip, middle income group, home based walk trip, high income group, HBS, and so on. So, once we have done that, then we have demand segment, which is like it is exactly we can classify further categorize demand strata into strata by different modes, and that is demand strata is divided into different modes, and each mode is one segment, and it is the link between transport supply and demand. A demand matrix is assigned to each demand segment and used for assignment calculation. So, let us see how we create this demand strata and this particular this different activity pairs first. So, we create demand from over here, and over here we can add the different demands. We can add new groups, like for example, we create a new group called students, and new groups of travelers called university students, and activity pair is they would be going for universities. So, this would be university trips, and then accordingly we would create the demand strata. So, this is we are adding this activity pair, home based pair, homework. So, over here we can change it into this activity pair into university or home to university trips, we can call it. So, we create demand strata, and once we create demand strata, then again we can actually we can again do it for this we can link demand strata with that particular trip purpose. We home university, this is the demand strata that we are creating over here, and once we are done, then we can go to zones, and we can go to the trip generation and attractions for all zones, and we see that these are not yet calculated. So, these have to be populated. So, we have to run the trip generation model, and in some of this, and we also have to define certain constants and coefficient for the different modes for initiating the calculations. So, this is how we start with the model. So, these are initializing the model, and once we have done that, and then the next step would be to run the 4-stage model. So, I will come to that. So, before we run the 4-stage model, we actually have to determine what would be the sequence of steps, and that is first considered. And for example, so we will define the procedure sequence in the menu bar, calculate procedure sequence, and we can save those files. So, we can load a file over here. So, this actually shows the procedure sequence. So, if you look carefully, there are different, we first create the calculate PUT schemes, calculate the different network schemes, we do trip generation, and we can also have the different trip distribution, mode choice, and then we have got the different matrices, and then we can also have an iterative loop going over. So, first we can modify the trip generation because we entered a new activity pair. So, this is where the trip generation is being modified. So, these are the trip generation equations and these are the trip attraction equations. So, we are modifying those equations. So, this is how we can modify the trip generation part, and once we have done that, the next step we can modify the trip distribution part. So, there again we can add those new trips that we have added, and once we have done trip, we can edit that, and here in the trip distribution we can use the same impedance and like the other for home university trips. So, for this demand strata we use the same equations, same utility equations. These are logit equations, log sum values are used in the for distribution, same as it was done in the cube model that I was showing earlier. So, this we just copy paste the same data. So, we use a logit function and we do it, and then the next step is mode choice, where we modify the mode choice for all these different options for the different demand strata, and here you can see the mode choice equations. So, for home shopping there are 3 modes. So, there are 3 utility equations. So, we can use the same utility equations for the home university trip as well. So, now that we have got our full equations, we are ready to run the model, and then we run the model. So, just look at the arrows. So, over here it is going in sequence, and now here it is looped because there is assignment. We do several loops over here, and until unless there is convergence. So, we do the PT assignment, and then finally, we have convergence. So, you can see the number of iterations going on. So, all the zones, so trips are now distributed between all zones and assignment is done. So, this actually shows we go back to the zones table, see all the trip productions, attractions are now populated, and finally, we can also see the other files as well. So, these are the references you can use. So, to conclude, we just saw how to execute the 4-stage travel demand model using both the softwares. So, we can say that Cubebase, in case of Cubebase, Cube Voyager and QubeGIS can be used to create the 4-stage travel demand model. CubeScript can be used to either modify or build new models at each stage of the 4-stage travel demand model. And then transportation demand modeling software integrates the links and links the different stages of the 4-stage modeling process. However, individual models for mode choice and trip generation have to be estimated separately. So, primarily this actually helps us to execute for the modeling process much faster. So, that is why we have to have these softwares either for 4-stage models or even for building activity based models, which would be taken up in the next lecture. Thank you.